Now, what do we have here? We have 2 points on a line L. I'm just going to call them A and B. Okay, there's a line called L, and there's A and B that make the line L. Shh. Now, do everybody agree with that? There's a line L, and it contains 2 points. We all happy with that? There's a second line K. K contains another point. We'll call that the point C, and we'll do it in blue. This is the point C, and it tells us that K has to be perpendicular to L. So what does that mean? What does it mean if it's perpendicular? Yeah. Now, how many points the whole object is to find the equation of K? Which one's K, the red or the blue? The blue is K. Had to find the equation of K. So I need y minus y1 equals m into x minus x1. What ones can I fill out right away? We know y1 and x1, don't we? So we already have y take away 1. And you get marks for this, by the way. You get marks just for doing that. What we missing? We're missing the slope. Are we able to get the slope of this right now? Why? We only have 1 point. It's not good enough. So we're going to look elsewhere. What we're going to do instead? Get the slope of A, B, and do what? Flip it upside down, right? So if you know what you're doing, you can have a look at 14. If you're stuck on 13, you can stay with me. And we'll do this now. So I'm going to use A and B here. So x1, y1, x2, y2. So what's y2? So what's y2, lads? 4. Okay, y1. 4 minus 2 all over. Minus 1 take away 2. I'd say the answer is 2 over minus 3, which to me is minus 2 over 3. Who got minus 2 over 3 for the slope? Turn it upside down, change the sign. What you get? So there's a basic misconception you have. Positive fractions always change to negative fractions. Negative fractions always change to positive fractions. So it's got to be a plus. And then 3 over 2. Is that okay? So 3 over 2 goes here. Multiply it out. 2y minus 2 equals 3x plus 12. Bring it to one side. Okay. How many people closed it out there? They have we have a boy, when he's 12 years old, he was 140 centimeters tall. So 12 and 140 is a point. That means you're 12 years old, you're 140 centimeters tall. When he was 16, he was 170. You draw, using an appropriate scale, show these points on a coordinated graph. And it only wants us to go in between 12 and 16. Do you see that? Only wants us to go between 12 and 16. So here's what we're going to do. Do you think I should go all the way back down to 0 centimeters? It's a long way, isn't it? So what you can do instead is, do you know where you usually start off the graphs at 0 and you go 0, 10, 20, and then you got to go all the way up to 170 or whatever. There's a quicker way of doing it. You can do what's called a little mark in the corner. It's like a zigzag, like this. And what that means is that it goes on all the way down to 0. And you do the same thing here. And that just means it goes all the way to 0. So you don't have to draw all the way to 0. Does that make sense? So, given that we did that, what's the first age we can put in then? Call that 12. I might just skip 3 blocks every time just to make it neat. The tighter you have it, the less neat it'll be. And I only have to go all the way, I have to get 20, don't I? So how far should I go up? Lucky for me, I can do that. Everybody cool? That goes up to 20. Now what way should I do this? That's 140. What we do, every tree should be worth 10. Try it out. Actually, do every 4. It's just a better number, I hope. Every 4. Where am I? 2, 3, 4. There it is. 150. Another 4. 160. Another 4. 170. If 4 blocks is worth 10, how much is 1 block worth? 2.5. We all good with that? Not 25. Each block is worth 2.5. If I put a mark here, what height is this? 177.5. We put a mark here, how much is this one worth? 192.5. Okay, let's try this out. So where's 12 and 140? Located there, isn't it? 16 and 170? It's located here. What can we do with our graph then? Go through the point but extend it onwards. Now unfortunately for us, that's the graph there. Oh. It wants us to go back to 9 years old, so we obviously made a mistake, didn't I? Now, so when you guys are doing this graph, don't start at 12, start at 9. Does that make sense? Okay. Now, how can I fix that knowing that I've already... So, look, you could redraw it, or you can just take away the slope. What happens every year? So, he's at 12, 140. What about 13? Actually, guys, just get the slope of it. Let's get the slope. 170 minus 140 over 16 take away 12 is, what's it, 30 over 4, 7.5. Every year you grow 7.5 centimeters. So when you're 13, you're going to be 147.5. Let's take that away. So look, if it's 12, 140, what's going to be 11? 11 and 132.5, 10 and 25, 9 and 17.5. I estimated that pretty quickly, didn't I? Just reversing the slope and going backwards. What about 20 from your graph? What do you reckon, 20 and 200, is it? Let's find out. Straight up, straight across. He's 200 centimeters tall at age 20. Form an equation that describes the boy's growth. What chapter is this in? The equation of a line. Okay. Okay, quickly does it. What's a point on the graph? Do we have any points there on the graph? We have that one there, don't we? Y take away 140 equals, what's the slope? 7.5 times x minus 12. Okay, give me a second for that. What's 7.5 times 12? I think it's 80. 90, excuse me. 90. Y minus 140 equals 7.5x minus 90. Y on its own is 7.5x plus what? 50. Now guys, what is the Y value in my graph? What's the Y value? The Y value is the height, would you agree with that? What's the X value? Age. What would you say about the Y value then? The height equals 7.5 multiplied by his age plus 50. Let's try it out. What height was he when he was 16 again? Okay, so 7.5 times what? What's now his age? 16 plus 50? 170, isn't it? Let's try for 20. 7.5 times 20 plus 50. Oh, so this equation actually tells us everything. This equation gives us every height for every age, just by inputting in. Done. Why is this not a good method of predicting heights? You're not going to keep growing in your 30s, are you? You're going to slow down growing. And what Heyman said is you're not guaranteed to go up the same amount every year. If growth occurs in stages, could height be described by linking sections of different lines? Explain your answer. You could say that after a while. Imagine you grow in a straight line for 2 years, and then you might get a bit. What happens then? Your height starts to, your level of growth starts to increase. So you could say that you could link it up using different slopes every time. Show a possible graph on the same page, making sure to show the correct heights. That's okay, yeah, that's the same graph. Done. Everybody right? What did I do in there, Dave?